Lesson 1 of Chapter 5 is on trigonometric identities. So you should already have these reciprocal identities on your note card. We've talked about how sine of theta is equal to 1 over the cosecant, and so the cosecant of theta is equal to 1 over the sine of theta. However, you might not have these quotient identities. So tangent of theta is equal to sine of theta divided by cosine of theta. And likewise, then cotangent of theta is equal to cosine over sine. Why is this true? It's just an identity, which means it's always true. So if we compare the tangent of 5 degrees to the sine of 5 degrees divided by the cosine of 5 degrees, they should be equal to the same thing. So this is true no matter what angle you pick. So if we did the same thing with a different angle, tangent of 7 degrees, compared it to the sine of 7 degrees divided by the cosine of 7 degrees, you get the exact same thing. So that's why it's an identity, and we will use it in this lesson. And so our first example, part A, tells us that the cosecant of theta is 7/4, wants us to find the sine. Well, since you know that cosecant and sines are reciprocals, pretty simple problem here. You know that the sine of theta would have to be equal to 4/7. Now part B is a little bit harder. It says the cotangent of x is 2 over the square root of 5, and it tells you the sine of x is square root of 5 over 3. We have to find the cosine. Well, from the quotient identity, the cotangent of x is equal to the cosine of x divided by the sine of x. So let's plug in these values here. We have 2 over the square root of 5 for cotangent, and we're trying to find the cosine of x. And so the sine of x is square root of 5 over 3. So now what I can do to solve for cosine is I can multiply both sides by square root of 5 over 3. And in doing so, you can see that the square root of 5 over 3 cancels over here. And on the left-hand side, the square root of 5s would cancel, and we'd be left with 2/3 equal to cosine of x. Another example of the same type of problem, you can see part A says secant of x equals 5/3. They want us to find the cosine. The cosine is the reciprocal of secant, so it's just going to be 3/5. Part B is a little bit harder. Part B gives us the cosecant of beta. It gives us the secant of beta. It wants us to find the tangent. Well, from the quotient identities, we know that the tangent of beta is equal to the sine of beta divided by the cosine of beta. And from the given information, we know that the sine of beta would have to be equal to 7/25. The cosine of beta would have to be equal to 24/25. And so if I put those values in, we should be able to get the tangent. Let's see here. Sine of beta is 7/25. Cosine of beta is 24/25. This is a complex fraction. So if you take the top times the reciprocal of the bottom, then this is gone. And you can see you can cancel your 25s. So we end up getting the tangent of beta equal to 7/24. Now, the next set of identities we're going to talk about are called the Pythagorean identities. So you're going to need to add these onto your note card. We have sine squared of theta plus cosine squared of theta equals to 1. And underneath that on your note card, I'd like you to write sine squared of theta equals 1 minus the cosine squared of theta. You can see all I did was I moved the cosine squared to the right-hand side of the equation. And similarly, we can write down cosine squared equals 1 minus sine squared. So make sure you have those three identities. They're essentially the same identity. They're just written differently. Have those on your note card. The second one then is tangent squared plus 1 equals secant squared. I'd also like you to write tangent squared of theta equals secant squared of theta minus 1. And I'd also like you to write that 1 equals the secant squared of theta minus the tangent squared of theta. Same Pythagorean identity, just written differently. Have those three written on your note card as well. The last one is cotangent squared of theta plus 1 equals the cosecant squared. I'd also like you to write the cotangent squared of theta is equal to the cosecant squared of theta minus 1. And I'd also like you to write 1 equals the cosecant squared of theta minus the cotangent squared of theta. So make sure you have those 9 identities written on your note card. So we're going to use those on example 2. Example 2 tells us the tangent of theta is equal to -8. It tells us the sign is positive, and we have to find the sine and the cosine. Well, the Pythagorean identity that I would like to use is tangent squared of theta plus 1 equals secant squared of theta. So if we take the given information, we can put -8 into this, and we should be able to come up with the secant value. So we're going to get 65 equals secant squared. So the square root of 65 is equal to the secant of theta, which then means that the cosine is the reciprocal, 1 over the square root of 65. Well, we should rationalize that into the square root of 65 over 65. So there's one of our answers. And then to find the sine value, there's a number of different ways we could do that. Since we know that the cosine value is 1 over the square root of 65, I can use this Pythagorean identity, sine squared plus cosine squared equals 1, and I can put that cosine value in. So that's going to give me sine squared of theta equals, if I square that value, I get, well, I got an equal sign here in the wrong spot. I get 1 over 65, and then if I subtract 1 over 65, that's going to give me 64 over 65. Then I square up both sides, and I get my sine value to be 8 over the square root of 65, which rationalizes into 8 radical 65 over 65. Here's another example of the same kind of problem. Here they're asking us to find the cosecant and the tangent, and they're giving us the cotangent. Well, tangent of theta should be pretty simple. Since the cotangent is -3, our tangent is going to have to be -1/3. And then to find the cosecant value, I'm going to use this Pythagorean identity, cosecant squared plus 1 equals cotangent squared. Put that down wrong. It's cotangent squared of theta plus 1 equals cosecant squared of theta. And so if we put in that cotangent value, should be able to find the cosecant value pretty easily. This gives us 10 for cosecant squared, so the square root of 10 is your cosecant value. So just using these identities and substituting in values. Let's just do one more example. You can see that this wants us to find the cotangent and the secant, and they're giving us the sine. So I'm going to use the fact that the cosecant should be equal to 6, the reciprocal of 1/6. If I use that with this Pythagorean identity, we should be able to find the cotangent value. So let's see here, that's going to give us cotangent squared equals 36 minus 1 is 35. And so the cotangent of theta would be the square root of 35. And then to find my secant value, I'm going to use this. Sine squared plus cosine squared equals 1. And so I'm going to substitute in the sine value to find the cosine value. That's going to give us, see here, 35 over 36. If we square root both sides, we'll get the square root of 35 over 6, which means that the secant value should be the reciprocal of that. So if we rationalize that, we get 6 square root of 35 over 35. So there's your secant and your cotangent.